So, lesson 9.2, you can title it something like squares and circles. And what I mean is that one of the things that we look at about a circle is what is the distance around a circle. That would not be squares in circles. But then the other idea is what's the area of this circle. And to measure an area, obviously we always measure in square units. So that's why I have that clever little title there. Okay, let's look around the shape. If I go around a circle, there's two ways to think about that. I could measure, the formula says, to approximate it, find the distance by taking pi times diameter. You might be wondering why I say pi times diameter. And by the way, twice the radius is the diameter. Pi, we don't know what it is, right? It's an approximation. So when we answer this, our answers should be in the form of, say, I don't know, 6 pi inches. All right? Don't bother like rounding off pi and going with like 3.14 or 3.15 or 3.141592, right? Just 6 pi, all right? And we'll let whoever, if it says approximate to nearest hundredth, I suppose you could, but I prefer you to leave them in exact format. All right, second, a part of a circle is called an arc. And a part of a circle then would be, so we take our circumference times the percentage. So that should be kind of an obvious idea, that since we only want a part of it, what part of it do you want? Well, one way to think about that then is to say, okay, how many degrees out of 360 am I staring at for my arc, right? So if I think about that arc, what's the angle that it spans? By the way, we call that angle a central angle. More on that in just a moment. Again, reminder, area equals pi times radius squared, aka radius times radius. And again, don't forget when you answer this, always write units squared to the second power, okay? So units to the second power. Again, if I want a sector or a part of it, we get then similarly a percentage times the area, right? How many degrees out of the 360 am I interested? In this case, looks like maybe 87 degrees out of 360. Don't worry, yours aren't going to be that difficult. They'll give you nice numbers to work with, not 87. Two differentiations. When we're working with arcs, they can ask for the measure or the length. The measure is in degrees. All right, so if I give you an answer and say, what is the measure of arc AB? You would go bam, bam. That's how I measure it, write it out. And then we would say, 68 degrees. Now I could also say, what is the length of an arc? All right, and that is measured in units. So it's like 56 millimeters. All right, if you're an ant and you are walking along this little path, right, how long is that path? It might be 68 degrees in terms of the angle that we're covering, but how many inches in it? Again, to get that, you would go back up to here, right, and you would take 2 times pi times the radius times the percentage, and that would give you the length. We'll do a problem of that right here. So the first question it says is find the measure and then find the length. So what is this arc AB? Well, we can clearly see that because we're going from one axis to the axis and those axes are perpendicular, that our measurement is 90 degrees. But the length, slightly different. We want 1/4 of the circumference. So here is the circumference, 2 pi times 6, aka 12 pi. So in essence, we have 12 over 4 pi. See how I took the 1/4 and the 2 and the 6 and smushed those all together? So the answer would be 3 pi units. Now again, if you rounded that off, say to the nearest thousandths, it would be 4.25. Okay? Again, in this case, they don't tell us the units, so we just put units. Now, if it asks you what is the area of this sector, then again, I got to use the area formula. So notice we start off here with pi times 6 squared. And how much of the circle do I want? Well, it's 1/4. You could say something like 90 over 360. But that ratio is going to simplify down to 1/4. So it's going to be 36 over 4, right? If I'm thinking about 1/4 here. And I believe that's 9 pi. So write it out again. Roughly, it's probably 28 or 29 units squared, but we're just going to write out 9 pi units. So a few definitions here in case you are unfamiliar with circles. Let's start with simple ones. Diameter. Okay? Diameter goes from edge to edge through the center. So it joins any 2 points on the circle as long as it contains the center. Now say you take other 2 points that are just random points. Why then that's not a diameter, it's called a chord. Okay, so this is a chord, this is a diameter. A diameter is a special chord. Okay, so this is special because it contains the center. How about an inscribed angle? There's an inscribed angle. It's an angle whose vertex is on the circle, and it cuts off, yeah? Fancy word for it intercepts an arc. And that's what is our second definition here, a intercepted arc. So an intercepted arc always has an angle that is coming at it. Now, by the way, you could have, say, a central angle. You could have a non-central angle. So you can even have then an inscribed angle, you know, kind of cutting off that arc. So an arc can be intercepted with many different types of angles. Mainly, in this book, you're going to deal with that type of angle. So that's called an inscribed angle. Again, the vertex is on the circle. Little rule that you have to know. Make sure this gets in your notes. There is a relationship between the intercepted arc and the angle, okay, the inscribed angle. And the relationship is that you would double the angle on the exterior to get the measure of the arc that's been intercepted. So an example of that is this particular problem here, where they're giving us a circle. You have angle E is intercepted, sorry, is a inscribed angle, and so we have an arc, and that arc measures 80, sorry. So we take 80, and we get half of it, and that gives me the 40. So the measure of angle E is 40 degrees. Hopefully that's not too confusing. It's a simple little rule, but it's a rule nonetheless which you have to remember. Hopefully that makes sense and you are able to do the homework problems now.